Okay, guys, the third lecture of Yarn. Okay, in this lecture, we're going to talk about resource requests. This part, what is important in short, is a concept called locality. Okay, right here, locality. Basically, we need to understand when a Hadoop application go to Yarn and request for resources. Okay, then what happened? So here we go. Again, the resource will be requested through a Yarn, and the resource will be represented by container. Okay? The container is simply a wrapping layer for memory, and a combination of memory and the CPU. Okay. When an application requests containers from Yarn, okay, then the application is allowed to specify the constraints of locality. Because what matters for Hadoop is that it makes, okay, what's important, why people love Hadoop, because it makes distributed computing such an easy job. Okay, and distributed computing is the solution for big data analysis. Okay, and how Hadoop make a distributed computing easy, because it provides MapReduce, Yarn, and HDFS. Okay. How? Now we understand. Try to understand how Yarn work out to support distributed computing. That means when there's a multiple applications have been submitted to Hadoop, how Hadoop allocate the resources and distribute the resources fairly among the applications. And then first question we need to answer is that what happens when the resource is requested? Locality. Locality, what it means. We explained this in HDFS, also in MapReduce. So as you see, locality is very, I cannot say important, it's probably critical, okay, for the success of Hadoop. In Yarn, what locality means. So multiple applications submitted to Yarn, and some application can make specifications to Yarn, say, my application, this application needs strict locality. That means, Yarn, please schedule my computation on the node that containing the data. Okay. So application can specify that, can tell Yarn to do that. Okay. And if the locality requirements can be met, that will be perfect. Okay, no questions, all good. But the problem is that it's not always guaranteed to meet the locality requirements. So sometimes a MapReduce application is submitted, and all the computation was scheduled with the perfect locality requirements. But what happens if the locality requirements cannot be met? Okay. So here, no location is made, or optionally constraint can be loosened. That means if Yarn tried to schedule the task on the data node that containing the source data, then that is perfect. If they cannot do that, why it cannot do that? Maybe the node that containing data was very busy, have no more resources to start a mapper task. Then Yarn cannot create a mapper task on that node. Then this is no locality. Then yarn have several choices. First, no allocation is made. That means simply return to the application. Say, well, I cannot make your application with your locality requirements. So you have to restart it, your application request. Or yarn can loosen that requirement. Say, well, I tried to with your locality requirements, but it failed. Then I'm gonna try the second best solution. That means if I cannot schedule the computation just on the node that contains the data, and I try to start application computation on a node that is very close to the data. Okay, so the second best. If the second best cannot be done, then we simply try the third best. So as we see before in the previous chapter, that there's several layers. Like the best is a local. The second best is the same rack. The third best is a different rack but the same data center. So so you're gonna try in that order to try to schedule that task. Okay, I think that's the important knowledge that we need to know in this section.